your homework and it says, you know what, you need to have it in perfect square form. Ryan, what does that look like? Perfect square form. A what? A squared plus, do you remember that for a perfect square trinomial?
Yeah, so A plus
A squared plus 2
A
AB, does that make sense?
Yeah.
Plus,
C squared.
and it could be a plus or this could be a minus, right? So when I'm looking at this, I want to factor this. I want to think, oh, what would those factors be? It would have been x, right, plus 7, because I take the square root of 49 and the square root of x squared. So what are my middle terms when I look at that, Samantha? One of them would be, if I do 2ab.
2x times 7.
Yep, so I have C could be 14. Or, Joey, it could be,
C equals negative 14.
could always be negative 14. Does that make sense to everyone, how those two values? This is kind of your A is the x. This is your B for 7, and you're kind of just looking at that middle term, the 2AB. Okay? Number 31 and 32. 32, my hint would be, how did you do any of these questions, 24, 25, 26, 27, 28? In order to complete the square, the lead coefficient must be, so you should be able to answer that. What is our lead coefficient? The next thing, if the coefficient is not equal to this, what do you have to do for the steps for completing the square? So I am not going to answer 32, but in how we did question 31, that's really what you're doing. In 31, you're looking at finding the volume, which is 10,800 cubic centimeters equals to length times width times height. And they tell us we have 12, we have 3x, and 2x plus 1. So we're going to go 12 times 3x times 2x plus 1. 12 times 3x is going to give us 36x. And now you're taking that times 2x plus 1. And that was still equal to the 10,800. So we now have a new equation of 72x squared, correct? Plus 36x was equal to the 10,800. So, what does our lead coefficient have to be as I'm looking at this, Mary? It has to be 1x squared. So, in answering 32, the lead coefficient has to be 1. What do you have to do? What you're doing right here. You have to divide by whatever that coefficient is. So we now have x squared plus 1/2 x. What you guys get when you took 10,800 divided by 72? So that goes here. And we are going to add on another number. What do I have to add to both sides, Otto? I'm going to take my b, right, which is 1/2, divided by 2, and square. So I have 1/2, right, divided by 2, which is really going to be, how much do you get in your parentheses? 1/4. So I'm going to have 1/4. It's going to be a positive 1/4 squared, which means I'm adding 1/16 to both sides, right? So this is 1/16. This is my 1/16. So as you're answering 32, this is kind of what you're looking at. This should be x plus 1/4 here equals when you added those two. X plus 1/4 equals the positive and negative square root. Why did number 28 come out no solution? What happened in 28 that you got no solution instead of solving it? Abby, what happened to your 28 that you couldn't solve?
It was a negative number.
It was the squared. You should have gotten it down to this squared was equal to this coming out to be a negative number. And anytime anything squared equals a negative number, you're going to have no solution. So I had some people going through and solving it and trying to take the square root of that. You can't take the square root of a negative number. That's going to be an algebra 2 when you do that in your imaginary. So, looking at those. Set your worksheet totally aside. I don't want you working on anything. You're going to have hopefully a little bit of time towards the end of class to work on that. There is going to be a quiz on completing the square, but we're not going to do it today. It will be probably either tomorrow or either Wednesday or Thursday this week. So as you look at the schedule. Yeah. So 3 forms of an equation. When we started this unit, the only thing we looked at was standard form. We now have this form. If you remember our cards from earlier, this told us our vertex. When we did those cards, the vertex was at the k value for our y, and it was always opposite, so I'm going to put minus h. And this really meant it was always the opposite of h. So when we started this unit, we always said, oh, in order to find the vertex, you got to find the x-coordinate, negative b over 2a. And then you had to go through all that work, and you had to make that table of x, y values. We want to be able to simplify it and look at our solutions. So the factored form gives us our roots, r1 and r2. And they're all kind of similar to when we think about slope-intercept form. We had point-slope form and standard form. So of our linear equations, there were 3 different forms, and now of quadratics, we have 3 forms too. Vertex form, this is like we just did. This is completing the square. So please write vertex form, completing the square. So anytime you're thinking of vertex form, you're really thinking, oh, I have to get it in that form of completing the square. Factored form is what it is, you're factoring it, and standard form is in this one. So when we look at this, we want to think about what are all these letters, A, B, C, what are they telling us? What do we know about our equation? The A is always going to tell us the direction and the width. Okay? Key things, direction and width. The C is kind of tell us where our y-intercept is. And then when we take a look at the A and B together, that helps us determine our vertex. Okay? So that C is going to help us with our y-intercept, meaning that it's whenever x is 0 in this form, this is going to be where it crosses the y-intercept. That doesn't mean it's the vertex, right? It just tells us the y-intercept. The A tells us direction. If the A is positive, right, our parabola is going up. If the A happens to be negative, our parabola is going down, and it has a maximum versus having a minimum, right? So you're going to be asked those things. You're going to be asked about your domain and range in tonight's homework again. When we talk about the width, if the A value is between 1 and -1, meaning it's a fraction, right? And the closer it actually gets to 0, okay, whenever we're looking at that, it's going to be wider. Meaning that if I'm looking at a parabola and I want it to be really wide like this, that might be 1/10 versus 1/4 is going to go up a little more and 1/2 more. And if I wanted 1/15, right, it's going to be even wider. Whereas if I am talking about a narrow graph is going to be where I'm looking at the A values being greater than 1, or where my A values are going to be less than -1. And the farther they're away from 1 or -1, the narrower it gets. So if I'm looking at -10, that's going to be a much narrower parabola than if I have -4. Right? -2 is not going to be as narrow. -4 is narrower. It's going to be closer together. Does that kind of make sense? And this doesn't determine exactly the vertex, but it helps us to place it. All right. That next part down in your notes is the vertex form. So this is the first of the 3 forms that we're going to look at that gives us a lot of good information. Again, You saw this on those flashcards when we lined up those ones and we had to find the vertex and tell if it went up or down when we looked at those cards that I handed back to you that we worked with earlier before the quiz. The A affects the width and direction. Vertex form, it is always x plus h, not the minus for our equation. So when we look at this, what is my y value, Tanya, of our vertex?
9.
Should be 9. Becca, what is my x value going to be? So it's x minus 3, we're going to have,
The y value,
nope, the x value.
positive 3.
Going to be positive 3. So that's why I like to think of it as the opposite of when it's x minus. So if we see minus 3, it's always the opposite of that, 3, 9. So you're going to be given an equation like this in your homework, and it's going to say, all right, tell me the vertex. We do not want to go through the work that we did before. We want to change this by completing the square. So if I'm completing the square, first thing I have to do is get the x squared plus 12x by itself. Subtract 34. We're going to be left with y minus 34. I'm going to put a plus and I'm going to leave that blank there because this is what I'm going to be adding to both sides. X squared plus 12x plus, and again, I got to add the same thing on both sides. Okay? And I'm going to find out what I'm adding to both sides. I'm taking that b divided by 2 squared, which is going to leave me with what if I think about this equation? What is my b going to be?
36.
Okay, wait. So I have what? First, 12 divided by 2, which gives me what in here? 6 squared. So what do I have to add to both sides? I like your thinking. We are definitely adding 36. Remembering that goes here, right? 36. When we go to factor it, that's where we're putting this value in, okay? So as I'm looking at this, we just added 36 to both sides. So as I'm looking at this, I'm now going to have y, and in this case it's going to be plus 2, is equal to, and this is where we now want to factor square. So if I'm looking at factoring it squared, Brooke, I'm going to have x plus x plus the 6. So this is where our 6 goes in when we are looking at that. That is the same as what we had here. So a lot of times some of you go right to this 36 and then you kind of go, what do I put in here? So if you leave both of these are your 2 answers when you get to this point. We are almost done. We're now going to get the y by itself. So Devin, if I'm going to rewrite it, y by itself, y equals quantity x plus 6 squared minus 2. So check with your shoulder partner right now. What is our vertex in this? Or the people sitting by you, what is our vertex? Write that down right now. Using this form of the equation, what is our vertex? And check with the people by you. Okay? Ryan, what'd you get?
-6,
-6, -2. If I was asking you, if we look at our original equation, do we have a maximum or minimum? Maximum or minimum? This equation. We have a maximum, right? Does everyone understand why it's a maximum? Why, Abby?
Because the square number is positive.
A is greater than 0, right? It's positive out in front here, it's 1, right? So A is greater than 0, so it's a maximum. If I was just going to do a rough sketch of this graph, what do I know my axis of symmetry is? What do I know my axis of symmetry is, Joey?
-6.
More importantly, it should be x equals -6. So here's my vertex, right? This is my -6, -2. And my parabola would be something like this, right? If I would plug in 0, what would be my y-intercept over here in this equation originally? This is going to be at what? 0, 34, do you agree? Goes way up to that point. Okay, so this gives us lots of information. Can I tell my domain? Domain on this one, Otto. x is equal to all real numbers, right? If I was looking for my range, Joey,
All real numbers greater than or equal to -2.
yes, looking at the y coordinate. So you're going to be asked in your homework about the minimum, the maximum. You're going to be asked about domain and range. And if you're thinking of what that graph looks like, even just a rough sketch, and this is going way up to 0.34 is where that's going to hit, okay? So that's all the different information that you can get from looking at an equation in a different form. Factored form of an equation. The R stands for roots. Besides roots, the other words we have used have been the solution, right? We've also called it our zeros, and it is also our x-intercept. Okay, so anytime I'm talking about those roots, that means the solutions to my quadratic, the zeros, or our x-intercept. So noticing that the minus sign, again, in the A, works the same way as in standard form, making it go up or down. So if we are looking at this, what are our solutions for x? Please write those first ones down, check with your shoulder part. My solutions. What are the roots or the solution? And if you want to leave it as x equal, or if you want to write it as an ordered pair, I take it either way. Do not multiply this out, right? I'm giving it to you this. This would be setting it equal to 0. The first solution, Tanya, would be negative 9. Second one should be 8. Does everyone agree? Negative 9 and 8. How would I write it as an ordered pair? Negative 9, 0, 8, 0, right? Devin, how about the next one? What are my solutions looking like?
7
and negative 5. Again, if I wanted to write it as an ordered pair, I could have the ordered pair 7, 0, negative 5, 0. Does the first graph have a minimum or maximum? If I'm looking at that. Talk to your shoulder partner. Do we have minimum or maximum on each of these two equations? Make sure you agree. Minimum or maximum, put that down right behind. Minimum or maximum that we're going to have. Thumbs up when I know you're ready. You've talked with your shoulder partner. Thumbs up when I know you've discussed it so that you're ready. Hannah, first one, what you guys say? First one is going to have a maximum. So the parabola goes down. Does this parabola go down? Is that what you're thinking? It kind of looks like this, that it has a maximum. Right? Does it have maximum or minimum? What's our A value out in front? What number is out in front of this? 1. So if it's positive, this should be a minimum, right? So it has to be a minimum because my parabola is going to be going up, right? Because this A here equals 1. So knowing that now, what would you say, Abby, Brooke, what did you guys say for the second one, minimum or maximum? This one is going to have a maximum. This negative 2 right here, this negative is telling us that our parabola will be downward shaped, right? So that is that maximum point. Whereas here we're talking about when A was 1. All right, so we're going to start off with this one. It says write an equation in factored form. First off, what are our solutions as you are looking at this? Maria, what's the one solution over here? Negative 1. Second solution, Samantha, is what? 2. So when I looked at this and I had x plus 9, the solution was negative 9. X minus 8, the solution was 8. With your shoulder partner, please write what's going to be in our 2 parentheses. X and x. How can we write that in factored form? So shall we put this down first? Start with this. So if the solution was negative 1, Joy, what does that first parenthesis have to be? X.
X equals +1.
Okay, so if I tell you the solution is x equals -1. What has to be in this parenthesis?
X minus, or X plus
X plus 1. Second parenthesis, Ryan, has to be
1. X minus 2.
X minus 2. If I asked you now to write it in standard form, because some of your homework is going to say, okay, you got it in factored form, that's great. I now want you to put it in standard form. I need to multiply this out, right? So x times x is going to give us x squared. My middle term is 1x minus 2x, which leaves me at a -1x. 1 times -2, so using that FOIL or multiplying it out with that extended distributive property, this would be my answer in standard form. When you look at the answers in the back for the factored form, does it matter which parenthesis comes first? Does it matter if you have x minus 2 first or x plus 1? It does not matter at all. So just make sure that you have what's inside your parentheses is exactly the same. All right. So now as we look at this next part, we're kind of looking at what are the key features when we look at the factored form versus looking at the vertex form. So first thing I want you to do, looking at this equation, so key features. A lot of times it's going to tell us our vertex location. It might tell us our x and y intercepts. It might tell us the axis of symmetry, the minimum, maximum, the width. Is it going to be wide or narrow, domain and range? Depending on the equation, we can look at a lot of things. So looking at this first one, what would you write down is your vertex? Should be -1 and 4. Okay, -1, 4. Which then, the axis of symmetry, Becca, is going to be what?
-1.
Not just -1, and this is where a lot of you on that quiz did that. It should be x equals -1. So remember, anytime you have axis of symmetry and it says, especially that word equation, you got to have that equal, x equals. So we're looking at it, should it have minimum or maximum array? Maximum. Domain. Depth. All real numbers. Auto. The range. So let's think about what our graph looks like, right? If I'm going to graph this, -1, 4, -1, 4, this was my vertex here, right? -1, 4. We already said that's a maximum point, which means it's going like this, right? We don't know exactly, I mean, that's pretty poor parabola, but you kind of get the idea. All right, and the next thing we know is that if we are looking at this, that the domain was all real. So what is our range? So we're going to go with all real numbers, and then we're going to say less or equal. So my hint is if you're thinking of, and you're getting stuck on the domain and range, especially with the range, the other way you can write this, remember, for all real numbers, you could use this R, like the 2 lines, that means all real numbers in mathematics. And then you could say y, in this case, is less or equal to, and you're always looking at the y coordinate of your vertex. Would you say this is going to be a wide or narrow graph because of the 2, Tanya? It's going to be narrower than our parent function, right? If it would have been, and when we look at that bottom one, it's going to be much wider, okay? So as we are looking at that bottom one, it's going to be much wider. So we are going to start off on the bottom half as we look at this equation in factored form. Now, this doesn't give us as much information in factored form, but it does tell us, will we have a minimum or maximum? If I look at the 1/4, it's positive, it's going to have a minimum, right? Can I tell if it's going to be wide or narrow? It's going to be wide because of the 1/4. Can I tell the x-intercepts? They are going to be what? 5 and -3. And depending on how you want to write those, if you want to write them as ordered pairs, or the x is equal to 5 and -3, right? So the only one that's a little tougher to find is our axis of symmetry. And axis of symmetry has to deal with where our vertex is. And in this form of the equation, it's kind of hard to find our vertex. It's not in the vertex form, so what you have to actually do is you have to multiply this out. Because in order to find the x-coordinate of our vertex for this axis of symmetry, we need negative b divided by 2a. So we're going to start multiplying. Y equals, Brooke, I'm going to have 1/4 times. When I start multiplying, what am I going to end up with?
X squared
Yep.
plus 3x.
So plus 3x and a minus 5x is going to give us a middle term of what? Yep, negative 2x. And then my last term in each one, when I take negative 5 times 3, gives us negative 15. Okay, so I'm at this point. Abby, we're going to use that distributive property and take 1/4 times everything. So I now have y equals 1/4 x squared minus what?
Negative 1/8, half x.
Half x. And then that last one, we could just leave it as 15 over 4. We could rewrite that as a decimal if you wanted, we could just leave it in this one. I need to go back now and find the x equals negative b over 2a. So when I am looking at this equation, my negative b, Ryan, is going to be what?
1/2.
Okay, and we got to be careful here. We want, so it's going to be minus a negative 1/2 divided by 2 times, right? And then a is
1/4.
and 2 times a fourth gives us 0.5, right? And minus a negative half gives us 0.5. So what is my axis of symmetry? X equals, I should have half divided by a half equals 1. And my axis of symmetry is going to be x equals 1. Do we have to find the y-coordinate in this case of our vertex? No. It just says find the equation for the axis of symmetry. That's all they're asking us to find. So how did we find that? When it was in factored form, we had to use FOIL or multiply that out. You have to use that extended distributive property as you're looking at that. So there's going to be some questions at the end of the notes that say, how do you get from factored form to standard form? From standard form to factored form as we're looking at these, okay? So we have this equation. We want it converted in both forms. So the first form we want to put it in is factored form. I want you to think of what are your two factors of multiply to negative 15 and add to negative 2. Do not do that 8C method that you've done before, because the lead coefficient you don't have to. You should right away be able to tell me your 2 parentheses, right? When we're writing this one in vertex form means we need to complete the square. So check with your shoulder partner. What you should have in your 2 parentheses is you do that factoring form. You should be able to agree on that. Someone tell me what you have, raise your hand, what you have for your 2 factors. What do you have?
Negative 5 and 3.
So we're going to have x minus 5, x plus 3. Got to get a negative 2. Negative 5 times 3 gives us multiplies. My product is negative 15 and adds to negative 2. So at this point, we can tell our roots, right? From this equation, we can say our roots are going to be at 5, 0, negative 3, 0. Can we tell if it's a minimum or maximum at this point? Going back to our original equation, can we tell? Yeah. So at this point here is kind of what our sketch of our graph looks like, right? This is our y-axis, this is our x-axis. The first thing we know is that we have a point over here at negative 3, 0, right? And we also have a point over here at 5, 0. We said it's going to be a minimum, which means my vertex needs to be someplace down here. Let's complete the square. When you're completing the square, first thing you have to do is add that 15 to both sides. I now need to try and figure out what am I adding to both sides. This is where we take the b divided by 2 and we square it. So if I'm looking at this one, Abby, negative 2 divided by 2 gives us how much? Negative 1 squared, which means I should add 1 to both sides. So I'm going to put a 1 here, I'm going to put a 1 over here. In my factored form over here to the second power, what are you going to have, Joey?
Say it again, please.
Right in this parenthesis, what are you going to have?
X minus 1.
X minus 1 squared. Equals Ryan on the other side.
Y plus 16.
Y plus 16. I am now writing it in vertex form by getting the y by itself. So I go x minus 1 squared minus 16. Which makes sense if we were thinking about, at 1, down at negative 16. 1 at negative 16 is our vertex. It was a minimum. If we are looking at the range of this function, our range would be all real numbers where y is greater or equal to negative 16. Our domain would simply be all reals. If I was thinking about this axis of symmetry, where is my axis of symmetry? From this information over here, right? The axis of symmetry should be at x equals what, Anna? X equals 1. It's right along here, right? So if I was going to draw that parabola. Can I tell where it crosses the y line right here? Where should that be? Look at your equation in standard form. Way up here. If we replace x with 0, where should this cross the y-intercept at 0 what? What are you going to be left with? Negative 15, right? If I replace x with 0, x with 0 here, your only thing left is y equals, that is my y-intercept. So all that information we can get by putting it in these two forms, okay? Whereas earlier this year when we started this unit, the only thing we could really do was make that table of x, y values after we found the vertex, and then substitute those in and look at those values. So what does our vertex form look like? Y equals a, x minus h squared plus k. Factored form, you're still going to have that a, but it's x minus root 1 in the first parenthesis, and then the second parenthesis, the quantity, x minus root 2. So it's telling us our two roots, or our x-intercepts. And then standard form, ax squared plus bx plus c. That's the easiest one to tell our y-intercept, because if you replace x with 0, the y-intercept will be at c. That's not the vertex, but just the y-intercept. This one tells us our solution. This one tells us our vertex. So anytime you can have an equation that you can write in one of these forms, it really makes it much easier. What I want you to do right now is, as you look at these first 3 questions, how do you change from standard to vertex form? Vertex to standard, standard to factored form. I just want you to discuss those with your shoulder partner really quickly. And if I'm looking at standard form to vertex form, what I really want to do is complete the square. That's why we spent 2 days on that, and we really wanted to get that down, that you understood completing the square. Because that is our vertex form of our equation. If it's in vertex form, how do we get it from this form down to standard form? You're going to use that FOIL or multiplying. And then you're going to simplify. You're going to add the like terms together. So you might, if you were looking at this equation when we have y equals, say we have x minus 2 squared plus 3. We knew our vertex was at 2, 3. And if I now want to get it down in standard form, I'm going to take y equals, and I'm going to have x squared minus 2ab, which in this case would be a minus 4x. Taking negative 2 and squaring it would give me a plus 4, and then I have plus 3. So by simplifying this, so that was the FOIL part right there when we did that, and now simplifying it would give us y equals x squared minus 4x plus 7. That would be the simplified form of that. How do we change from standard form into factored form? Well, if I'm looking at this equation, right, and I want to go from standard form to factored form, I'm simply going to factor. Now, if I can't factor it, at this point, we're not going to go back. Like, this one isn't really nice and factorable. But if I have an equation and I'm looking at something that's in standard form, and I have something like y equals x squared minus 2x plus 4, right? I can think of that as being factored as x minus 2 times x minus 2. Can I tell what the solutions are? That is my factored form, right? There's only one solution, it's 2, as I'm looking at that. How do you change from factored to vertex form? So again, what are we going to have to do? We want to use FOIL, then complete the square. So that completing the square and the whole last chapter when we did factoring, when Mr. Lehman was here, knowing how to factor all the different ways of factoring. Perfect square trinomials, difference of 2 squares, all those special cases, those are going to come in handy as we finish this unit. And go into our last unit, which is kind of a combination of all the last things. So, vertex form to factor, you're going to FOIL, and that really just means extended distributive property. Simplify it, then factor. Factored form to standard, multiply it out and simplify. So as you are looking at these, all of these are going to kind of play into how we're solving our equations. Thumbs up, did everyone get those? Okay. So, tomorrow we're at the Red Hawks during class. You should have this I7 worksheet done for Wednesday. Most likely we are not getting back during 5th hour. The gate starts at 11. They say maybe 2 hours, so it might be probably sometime during this period. If it would be, we're going to come back and we're just going to have the rest of the time to work or finish this. Or if you're done with this, we probably look at Quizlet, but we won't. You don't have to have it turned in because we might not get back from the game until after. Okay, it might not be until 6 hours. Depends how quick it goes, how things go as we're at the game. As you are looking at this, make sure you read all the parts so that you get all the answers to the question. So in this one it says, identify the vertex, axis of symmetry, minimum or maximum for your x value, the domain, the range of each function. So I'm looking at all those things for 1 and 2. This one asks you to write it in, write the function that models the graph. So you might want to think of what form, like what do they give you when you are looking at number 3. To me, you know the vertex. Vertex form would be the easiest form as I'm looking at that, right? This one, very similar, vertex form. So write a quadratic function to model this equation. You can check to see that it gives you these different values. This one says write it in vertex form. Find the vertex. Rewrite it in vertex form, rewrite the equation, a different form than below, so they tell you which form to write it in. And then tomorrow, we are going to have either, depending, if we're back tomorrow and there's like 15 minutes, we might take a homework quiz on the completing the square. If not, it'll probably be 1 day later this week to just kind of see how you're doing on that. Use your time now to finish up